Hello everyone, let's continue with the chapter 2 for operating system structures. So for this chapter we talk about the following things. So that means the overall idea is that after we learn this chapter we should be able to know how to design operating system software. So and also we can understand the different components of operating system, because based on different point of view you may have different understanding of operating system. For example, you can think about just services. For example, operating system just provide services for us. Okay. You can also think about operating system contains some interface. So we'll talk about interface as well. And then the last one, you also can think about computer operating system has a list of components. So the components are interact with each other. And then that's just like a functionality analysis. So from different angles, you may have different understanding of the same operating system. Okay, let's think we'll start maybe for this week we can only finish the first two parts: operating system services and the interface. That means from these two angles, which services can be provided by an operating system, and which different interfaces we can have for operating system. Okay, and then next week we'll continue with the system calls, system service, and linkers and loaders for programming, running, and debugging and so on, development. And why applications are operating system specific. And then design the implementation is about some different strategies. For example, how can you design the architectural structure? Whether you have a kernel, or whether you have a layer by layer, or you just have different modules. So we'll be involved here. So these two, okay, and the structure. And then we'll talk about the booting. That means what is going on when we boot a computer. Okay, and also build. And then operating system debugging. That means which debug tools we can use for operating system. Let's start with the first one. So for this chapter, we have these objectives. The first one is identify services provided by operating system. So we look at different groups of services. Of course, you can think about this is have two parts. One is from user part, the other one is from operating system itself. So user part, which services will be provided to the user, and the operating system part, that means we want to make the operating system itself efficient, correct, convenient, and high efficiency, convenience, and like these things. So operating system is also like a customer of itself. That means it can help, for example, operating system related job scheduling, process synchronization, like we mentioned, memory and so on. Okay, and then we'll talk about our system calls. So system call, that means you can call this system call in your program. So we look at which type of system code we can do. So most important one is I/O, input output. Okay, but we have something else we'll talk about as well. And then we'll look at compare and contrast different strategies for operating system design. For example, we can have a monolithic, okay, just as a whole, and then layer by layer, and then microkernel. So you have a kernel, that's the most core part, and then build on the kernel, you develop the surrounding functionalities, and then modular. So you based on the different modules. Each module is responsible for some functionalities. Of course, they will interact with each other as well. And then also we have a hybrid one. That means maybe not just only adopt one of these, we can adopt multiple structure. Okay. And then booting, that means illustrate the process for booting operating system. So when we start, right, we power on the computer, what is going on there. Of course, we already mentioned this a little bit in the introduction, but here we give more detailed description. And then after that, we talk about how can we monitor the operating system's performance. We have some tools. Okay, I think you also ever used at least some of them, right? Like Windows, we have a task management, okay, task. And then design and implement kernel modules for interacting with the Linux kernel. Okay, this is about kernel module. Let's look at first one, operating system services. We want to look at which type of service need to be done by operating system. Okay. So here give one overview. That means this one is just put all the possible services, because this one is from the angle of services. That means if we look at the operating system, just provide services to our user. So which type of services operating system can provide? So this is just an overview. Let's look at, for example, starting from hardware, and then build on the operating system. This one is the shaded part. That means contain all of them. So this one has these services, and then system calls, and then user interface. Okay, let's look at maybe highest level, the user interface. This is easy for us to understand. We can use the graphic user interface, that's GUI. We can also use a touch screen like our mobile phone, okay? Mobile telephone. And then command line we also use, okay? Like DOS like. Okay, so that means this is just provided this type of user interfaces. Here we put three things together, means we may provide one or multiple, not only just like exclusive. Sometimes we have more than one, right? Like Windows desktop, we have both GUI and command line. And also for example, currently our operating system also can have the GUI, touch screen, and the command line. All of them are included. So today, the second section will talk about the different type of user interfaces. And the next one is the system calls. So system calls, you can find it's just in between, right? That means if you want to call the services here, you must use the system calls. You cannot use these services directly. So the reason, for example, you want to open a file. In fact, this one is also is like a program. Though you just only click, right? Or you read or open a file from your program. It has a list of operations must be done by a operating system, but we just wrap it as one function. For example, in C++, we use fopen and fread for reading a file. Okay? If, for example, of course, fopen means it's ARCS2 coding. If it's binary bit strings, we use fread. And write, we use fwrite, okay? Fwrite and fprintf. Okay? We have two API. That means we set this API just system calls. So let's look at a system calls. We'll call which services. So here we just list all of them. For example, we can run a program. You can stop. You can terminate. Okay? You can suspend, like these things. And I/O operation, input output. File system, you want to access a file in a file system. So you need to do that. Open read and open write and so on, append it. And the communication, So this communication, that means we want to communicate between processes. For example, you have one process here, another process there. That these two processes, they need to synchronize each other. So that's called a communication. For example, they share a common memory, right? We mentioned producer and consumer. And if like that, we need to have communication. Okay. Later we'll talk about we have two types of communication mechanism. And sometimes maybe you need to send the result from one process to another one. So you can use message or you can use shared memory. So that's the two methods for process communication. And then resource allocation. So that means you want to run your program, you want to read, you want to print your results on a printer or on screen. So you must make sure that the devices, the resources are available, and then you can do that. So this is resource allocation. Accounting, for example, they must log all the information for users. For example, how much time when you log out, like this one. So this one may be used for later accounting. Okay. And the error detection, for example, sometime we have read and write error, we have maybe divided by zero error. So for this error handling also be handled by the operating system, because your program will not do that. Okay? Of course, some code maybe have some type of exception handling, but still there's some basic ones will be handled by the operating system. And then protection and security, we mentioned you need to check the rights to read and write and so on. And then security, just make sure it's so protect, that means for user access. Okay? Security, that means we want to make sure the resources will be hidden from unallowable users. And protect, that means whether you have the correct privilege on, or privilege means operation on those data. Okay, if you can only read, you cannot write. Okay, like this. Let's because this is a lot of services, we'll look at one by one. So here we divided this one into two groups. The first one is from the point of view, which is user. Okay, from user. So we said operating system provide an environment for execution of programs and services to programs and users. So first, you must provide an environment which can run users' programs. Okay? Program means application programs, their code. For example, for development, they can run their program. And then not a development for end users, they can run some application. Okay. So of course, this is not that easy, okay? Because they share all the resources. Okay. So that means you have a process management, and the CPU needed for the running, and the memory also needed, and the I/O also needed, and also access files. So all of these things will be involved to run programs. Okay? Because our target, of course, just run programs on our operating system. So, but to support this one, we need to share a lot of resources. So, of course, we need to have an operating system which can manage all the resources. So, from this point of view, since it's easy to understand, because it's like a management of resources. So one set of operating system services provides functions that are helpful to user. We said you can think about operating system provide services for both users and the operating system itself. So we look at it from these two point of views. Okay, point of views. So for example, you can provide such services. Of course, this is only one part. Okay. Maybe only the first half. First one is the user interface. That's easy to understand. You want to interact with the hardware. in a convenient way. You must be provided by a convenient user interface. User interface is the software for people to interact with the operating system. So basically, we have different types. For example, command line, CLI, and GUI, graphics user interface. So that means they use graphics to replace the commands rather than just remember the commands. They design the GUI for you to interact with the user with the operating system. And then we have a touch screen. So for this one, we use gesture. For example, press, click, press, and just scratch. What to say? Just tap, just like a flip, just like these things. We use gestures, file or only our hands, fingers. Okay. And then we also have a batch command system. That means we can run a list of jobs together. And then of course the other one is that a user interface is only just like an interaction, is like a GUI or something just like the interfaces. But we also need to run our program, so that's the program execution. So for a program, you need to load from the disk into the memory, load the code and the data, So load the program and its related data into memory, and then we need to prepare it for just wrap this program into a process. So we said program is a passive concept, so that means it's static. But process is like a program in running state, so it must contain the program code, program instructions, means code, and also the data, and also related resources. So CPU, memory, maybe register, and devices for I/O devices. Okay. So that means we need to prepare for this one and scheduled by the CPU and then run. And sometimes if we cannot continue, we may need to suspend or end, like this. Run that program, end execution either normally or abnormally. For example, there's an exception. We need to stop the running. You have divided by 0. You have you just add something into a full maybe shared memory, or just read a non-existing file, or something, or write into a it depends. Okay, sometimes you can write it in a non-existing file. You can create one. That means if it causes errors, you need to stop the running of the program. And then we have I/O operations. For the program to be finished, sometimes we need to do I/O input output, read, write, and just write on the file, read from the file, maybe also print the result on the screen, like this one. So this one involves file and I/O device, monitor, keyboard, all of them. And the next one is the file system manipulation. So that means we can run, for example, use the operating system. We can store our data in a file system. So we must maintain that file system. Okay, how to name, how to find, search, and so on, like this. The file system is of particular interest. The program need to read and write files and directories, create and delete them, search them, list file information, permission management. So for all of these things, we thought it's just like some common operations we have for a file. So when we talk about the file system, file management, file system part, we talk about, that means this is like a privilege. Okay, read and write appendix, R, W, and A. So these are the most important 3 operations. Okay, and then also sometimes you can create, okay, you can delete, and also you can find, you can list. For example, you need to provide such commands, or just like you have the related system operating system surface, system codes. So we'll continue. That's not finished, because this is the first part, and then we have next one. It's for communications. We mentioned, so for processes, they may need to exchange information. So this means different processes, process 1 and process 2, they may need to exchange information. If like that, we need to use some mechanism. Okay, because for example, like this one, we may divide our task into multiple processes, and then we may just send the result from one process to another process. So how to send the results from one to the other? So we have the 2 mechanisms. One is called a shared memory. So like the producer and the producer and the consumer, okay? Producer and consumer, that's a shared memory. We use a common buffer to do this, okay? So producer and consumer. And the message passing is really like just like a network operating system. So you send a message, of course you must use a predefined format. For example, what's the head, what's the end, what's the in between the contents. So it's a message passing. So you will use this one. It's very like something we call you may have known the remote process call, okay, like these things, RPC. So that's called just a message, okay, message passing. And then there's the error detection. So we want to check any problem during the running of the operating system and the environment. For example, this one may occur in the CPU or memory hardware, in I/O devices, in user program. So this is possible for anyone. For example, you have a memory leak, you have some problem with the CPU. CPU there's a deadlock there. You must detect the deadlock and then correct the deadlock. And I/O devices as well, in the user program, whether the I/O is busy and then there's some conflict, so you must wait. It's non-exclusive access for the I/O devices, okay, like these things. And then for each type of error, it will take some action. So take some action, that means we need to, for example, just save the maybe state, and then promote the users this type of error, and then also maybe need to provide some message, okay, what's the type of errors. And then debugging, that means also we have operating system debugging. That means we can help the users to understand what is wrong, and then there's some tools will be provided. So debugging facilities can enhance the users and the program's ability to efficiently use the system. The most easy one is that you can track the memory CPU's usage. Okay? This is debugging, and also you can understand different processes, what's the current state for these things. So the operating system will also provide such things. Okay. So this is from the point of view of a user. Okay, from the user point of view. In fact, another set. That means this is in addition to the previous. Means it's not overlapped. Okay. So this one, that means we look at the system itself, because our target is that we want to make the operating system as convenient as possible, just make it easy for us to use. Okay? So we can just have these things. I think this one we already talked about before. Okay? We'll go for it quickly. For example, if we look at this one as a resource management, okay, then resource allocation. For example, if multiple users or multiple jobs running concurrently, so you need to find a strategy to do the resource allocation. Do not have deadlock. Okay, adopt a strategy which can avoid deadlock. If there's a deadlock, we can break the deadlock. So this is the resource allocation important things. It's very like some non-shareable, just like exclusive resources. Each time can only allow one user to access, one process to access that resource. So we need to consider these things. So resources must be allocated to each of them. So for multiple users, we need to guarantee each user finally will have a chance to be allocated those resources. So we cannot have the state, okay, put this operating system in a deadlock. Some users will always wait there and then repeat this cycle. There's no possibility to end the cycle. That's called a deadlock. We have many types of resources, like for example, CPU is the most important one, and the memory, file of course, in the disk, okay? And I/O devices. Disk is also I/O devices, but we still have a keyboard, mouse, and the monitor, printers, and the USB connected other resources. Okay, even if you use a VGA connected with a screen, that will be I/O devices. And then accounting. So from the point of view of operating system, it also need to keep track of all the users' activities. For example, later maybe they just use the time to do the accounting, and then check who is accessing which type of resources at what time, like this one. So how much and what kind of computer resources has been accessed by which users at any time. So we just track this information. And then protection and security. So the owners of information stored in a multi-user or networked computer system may want to control use of that information. Concurrent processes should not interfere with each other. So the basic idea is that here we want to make sure the resources have been used by the eligible users rather than by other ineligible users. Okay? So protection involves ensuring that all access to the system resources is controlled. So whether you can read and write and add appendix, like these things. Security is the system from outside requires users authentication. For example, like the login. Okay? You want to log into the system, and then you can continue to use the services, use the computer to do the work. Extends to defending external I/O devices from invalid access attempts. So basically, this one is just like a from the uttermost control, just like make sure this computer system is secured with some approaches. For example, you need the user ID and the password, and maybe of course you can use face recognition. But anyway, you can use some biometric or just a password method to assign control limits, control constraints, just whether access control, like this. Okay, even this one can be extended to the surrounding I/O devices, whether they have some invalid access attempts. Okay. So let's do the quiz. So the first one is the system call interface is the boundary between user programs and the operating system services. So from the previous figure, so this is correct or not? System call, okay, is the boundary between user program highest level and operating system services. So from this point of view, this system calls is being user programs. That's here, right? And so that means the access file here and the services. So that's correct. Okay. And the next one, GUI is the most common user interface. That's also correct. Not a command line, correct? Also not a touch-based interface. So touch screen is a user interface on mobile system. That's also correct. Yes. Okay. So all of them are yes, correct. Let's continue with the second part, and then after we finish, we stop here. Just look at this. We'll look at the first question about the important core part about the interface, correct? So user interface and the operating system interface. Okay, we talk about this one. So the first one is command line interpreter. So you can think about command line is like a short program. So we wrapped operating system services as a command line, and this command line in fact is core system services, and then can do one thing. For example, list all the files and the current drive, like this one, correct? So that means it call some services provided by the operating system, and then we wrap this one in one command. So this one allows direct command entry. So if you have that command line interpreter, you can just input lines. So in fact, in our operating system, if you run the CMD, sometimes I have this. It should be okay if we run this one. Because it seems like we need to go back. For example, we cannot use ls, but we use dir. This is for DOS, just like this one. So we want to list all the files, and drive. So we can have these things, okay. And then if you use Linux, you need to use ls, means list all the directories in the current drive, okay. So this is just command line interpreter. That's the example, okay. Sometimes we implement this one in kernel. That means we wrap this one in the kernel. That means kernel is must there. Sometimes we put this one as a system program. That means system program is like an application built on top of system services. Okay, for example, like we mentioned, a calculator, like these things. Okay, so they are. If you don't have that one, they can still be there. So it's like the operating system still can be usable. So that's built on top of the operating system services. We develop some small software. Okay. Sometimes we may use a hybrid way. So we have shells. Okay, shells. So we may just look at Linux. When Linux we have a shell. Shell, that means it's like a user interface. But this one you can only just shell like a outside cut. You can only use command line. Okay, you use this one to interact with the operating system. Okay, they provide such things, but in a user graphic user interface way, GUI way, so make it easier for you to call. So that's why we said it is like a hybrid way, right? Okay. And then primarily fetch the command from user and execute, just like what I did just now. dir, so that's a command, the fetch command. So accept this command and then execute it. So this is the basic pipeline for command line interpreter. So it's like a script-based system. Okay, each time run one script. Sometimes command line is built in, sometimes just names of programs. So sometimes maybe is already inside of the operating system. Sometimes maybe you need to use a command, use some programs names to call it. If later we add new features, doesn't require shell modification. Okay, because this one is not built into the kernel, okay, into the core part, in the operating system core part. So of course you need to add something new. You don't need to change. Okay, you don't need to change the shell. So let's look at this Bourne shell. Bourne shell means the bash. Okay, the bash also called the bash command interpreter. Give one example. So maybe different from what we have. So the DOS, okay, DOS one seems to use a lot. But here, let's look at. So for here, you can find this login, and then SSH root. At this one, this is just like you need to use a socket. So it's like a username. The user should be username, user ID, and the password. Do not show this password, and then success login, and uptime. So this one will show this uptime. I didn't look at this one, but you can find it. I provided some of them. Okay, for example, uptime Linux command. So this one is the meaning. Uptime tells how long the system has been running. Right? So for this one, so the show the result, how long the system has been running. Okay, sorry. This one is show this one up. This one up 16 days. So that means, of course, it should be started from the last time. Right? From last time, how much time has been elapsed. Okay, and then we have df_kh. So here I provided the link here. Just understand what it means for the df and the ps, because this one is df_kh. So basically this one you can find that we want to find the disk information, right? So this one is PS, is process information. Okay, let's look at the first one, df. If you click, you will get this one. df is a report file system disk space usage. So that means the disk relationship. Of course, if for our operating system should be easier, okay, it's easy to do. You can know what's the usage here. That's easy. You can also use this GUI and so on. But here, in fact, we want to use command line based method. So we need to use a command, okay, df. So you need, after command line, we have some options. Okay, we have some options. So here we have the ph, okay, ph or kh. So bar, okay, slash, short dash, okay, and then kh, okay, k is like the block size 1k, okay, So this is H is human readable. Print size in powers of 1024. Okay, so that's the basic idea for here. Let's look at for disks. For this drive, the file system size used, available usage mounted on, and then on this device, and this folder, this subfolder, we have this total size used, this number, available is this one, and usage is this one, and another file, another file system. So that means another, we can say is another, this is devices kind of like a drive. This is also another drive, but here is like a temper file is another node, where we say that it's a child of this file system. We have this usage similarly. Okay, so on and so forth. So that means list all the current usage for the file system, the file system, and then make it easy for us to read. So it's like a table. And the next one is PS. PS is for process. That's why you can find a list of process. And the AUX, you just want to list the information. So that's the meaning. Let's look at this one. Because the bash command sometimes we can also use for Linux. So that's why let's look at PS. P means process. S means snapshot. So report a snapshot of the current processes. So current processes means the processes which are running. Okay. And then we have AUX. So we know the meaning for AUX is okay. This is we have the we don't have this short dash. We only have for AUX. Correct. So this means anyway, we just want to print the information. You can read the details. Okay. So when we talk about process management, we may do some experiment for this one. So this one shows that this is different from this one. Okay. This one we print all in for something. Okay, so here we look at the details here. AUX sort NRK33 had this one. Maybe we need to look at the details in that part. So this is root, and we may have an ID for the process, and then have some other information. Maybe they use some resources as well. And this is the time information. Maybe starting time from when, and so on. Anyway, when we look at the process management, we look at it in detail. Here we just give you an idea. The target is that we have some command line interpreter which can help us to access the system's services. Like here we have the DF and the PS. Okay? So this is the main target for this example. And the next one is more popular, which is GUI. I think Windows just is more and more popular. Is most popular just because of GUI. We use GUI, but of course a lot started from Windows. Windows also borrow from some other successful examples. Let's look at this one. So this is the user-friendly desktop metaphor interfaces. So how we use the GUI to interact with the operating system? Usually we use icons. We use icons. We can use a mouse. First one we use mouse, keyboard, and a monitor. Okay, use these things. Use mouse. We can move and click. Use these things. Keyboard we can input. And then we have designed the user interface as icons. So So the icon can represent files, programs, actions. For example, you want to close something, right? So close, these are icons. Okay, these are also icons. This is a menu, right? You have a menu, and then you can just click the icons where that's called the related functionality. That's the callback function which make it work, right? So that means you click this menu, this icon, it will call the function. So the function will run and then will complete the task, rather than just memorizing all the commands. For example, I want to list all the files, I want to close something, I want to copy something, I want to check the property of something. We don't need to remember the commands. So for every common people, okay, everybody can learn it quickly, easily. So that's also the success reason for this type of user interface. Okay. So we have various mouse buttons. This means, for example, we put our mouse buttons on top of each icon. We have different meaning. It may be provide information, maybe provide some options, execute a function, or open directory. Open directory is also known as folder, right? So that means depends on the different icons properties, icons types. We have different actions. Okay. So this one, in fact, is invented by Xerox, not initially by Windows, okay, by Microsoft. So this is Xerox. I think you know this one, okay, for famous things for printer, okay, very famous one, printer. And the next one is many systems now include both CLI and GUI, like our Windows, of course, they have, and even the touch-based touch screen, okay, touch screen interface. So Microsoft Windows is a GUI with a CLI command shell, and Apple Mac OS 10 is Aqua GUI interface with Unix kernel underneath and shells available. So we know the Unix kernel, that's the Darwin, right? So Darwin, that means this one has the GUI which is borrowed from Aqua, and then but the kernel is the Darwin, is the Unix kernel, right? We use Unix kernel and then put Aqua GUI on top of it, but also provide a shell, okay? Provide shells which can help us to run command lines. So rather than just use a command line operating operate DOS one, they use a shell. Okay. And then Unix and Linux also have a command line interpreter, but also have some optional you can install. That means this is not shipped together with some operating system, Linux or Unix. But if you prefer that one, of course you can download that distribution. So that means you may have different GUI interfaces, because it's optional. You can choose this one or that one. It's like a close, okay? Same person, but we're just different clauses. So you can use different clauses. We list the CDE, 3 examples, KDE, and GNOME. So CDE is a common desktop environment, is a type of GUI for Unix or Linux. And KDE is for K desktop environment, and GNOME is for GNU. This is GNU's one, GNU network object mode environment. So that means you can use the same Linux or Unix, but with different GUI. Okay, you have more choices. Okay, and the next one is very famous now, okay, very common now, with a touch screen. So this one And why we want to use a touch screen rather than just GUI in related scenarios, for example, like a mobile phone, right? The reason is that those methods are not feasible or not workable for the mobile devices. For example, mouse. We cannot have a cell phone with a mouse, and even keyboard. Okay? Now we also don't use. There's no keyboard, only soft keyboard. Okay? Soft keyboard. So mouse is not possible, not desired. And the action and selection will be based on gesture. So press, click, or you can use a double click or something, or use gesture. Use our gesture. You can use just lift something and so on. You can also use a virtual keyboard. You don't need to have a real physical keyboard. You can use the virtual one, virtual keyboard for text entry. And also for convenience for us, it may also need to receive voice, listen to voice commands. For example, we are driving and we want to use the cell phone. Of course, you need not good to do that. But if you don't use your hand, okay, you can. That's safer, okay? So you just, for example, call something. Okay, call somebody. Just let it call. You don't need to put your cell phone. And then if you have Bluetooth, you can use your mic in the car, from the so it's just installed on the car. So that's the reason. And in fact, for this either iPhone or iPad, they use the Springboard touch screen interface like this one. This is one type of design, Springboard. Okay. So this one show one example. That means like a Microsoft OS 10 GUI, it contains both the GUI and the command line. Okay, I think maybe this one is the command line. These are the GUI ones. Okay, this show that means sometime this is, of course, we didn't mention. This is just like when we do the user interface selection, the choice, make a choice, you need to consider the requirements, whether we have this requirement. If we have this requirement, we need to provide such services as well. Okay, let's do the final thing, which is the quiz. Only have two. The first one is KDE and GNOME desktop are available under open source license. Yes, they are provided as open sources. Okay, their code is also available. And there's only a single flavor of shells for users to choose. No, we just show several examples. We have these things. Okay, you don't need to have only one. You have multiple different choices always. Okay, so that's fourth. Okay, that's all for this week's class. I think today, we have good speed, and then we'll continue for the rest of the thing. So chapter 2 is also a relatively longer chapter. After we finish chapter 2, the overview part is already done, and then we continue with the process, memory, and the I/O, and the file system, and protection, security, and maybe virtualization, and so on, like these things. Okay, so anyway, just as I mentioned before, in the first part, you need to prepare well for the environment and also try to integrate the learning of the operating system concepts with some operating systems learning and also some operating system based program learning. For example, I recommend you learning Linux and Linux based programming. I provide some books, and also you can look at online as well. And the other one is that do not forget install the virtual machine we mentioned, based on the virtual box. I showed the demo in the previous instructional video. Okay, that's all for this week's class, and then see you next week. Bye bye.